regex or regular expressions are notoriously difficult to learn because the patterns look like gibberish. And that's why you can see memes like this on the internet. So in this video, we will simplify regex with practical examples. Regex allows us to do two main things: find patterns and capture and return things. In finding patterns, we can tweak what to find, how many times to find, where to find, and in which surroundings to find. So what can we find? We can find literals, which means exact matches of literal characters. For example, if we search for card, it will match with cardiac, postcard, and card itself. This is similar to how Control F finds words in a document. Then we can also match collections. So if you want to find vowels, we can put them in a square bracket and it becomes a collection of vowels. And whenever it finds any of these, we have a positive regex match. Or we can put numbers inside a square bracket and then it can match any number inside the text. And the third one is classes, which are predefined collections. For example, /D matches any digits. /W matches word characters, that is any alphabet in a word. And /S matches with white space characters, except new line. So now we know what regex can find. The next thing is how many times to find. And this is called quantifier. So star means 0 or more times, plus means 1 or more times, and question mark means 0 or 1 times. So as an example, we can search for any characters for any number of times followed by com. So it matches john@gmail.com, john@yahoo.com. Now coming to plus, if we are not sure if somebody can put one O or multiple O's, we can write GO plus GLE. So it will be positive for GOGLE, but it won't be positive for GGLE because at least one O has to be present. The question mark or the optional character can be used in cases where the spellings can differ. So color can be written as COLOR as well as COLOUR. In this case, we can put a question mark after U and it will detect both the spellings. Now the next step, we can find objects at the start of the string, at the end of the string, at the boundaries of a word, or not at the boundaries of the word. So for example, if you want to find the STD code or the dialing code of a country, it has to be at the beginning of a string. We don't want to find it at the end of the string or somewhere else in between. So it matches the first two strings, but as you can see in the third string, even if plus, 9 and 1 are present in the string, it doesn't match because they are not at the beginning of the string. Similarly, if we want to verify if a site ends with COM, we can create a pattern with a $sign followed by COM. Now coming to word boundaries, they are not only restricted to the beginning of the string, but can be for words in between also. So if I am looking for US followed by a word boundary, the first and the second sentence are a positive match because the word USA starts with US and the string US is present at the word boundary. In the third and the fourth sentence, US is present but not followed by a word boundary. Hence it is not positive. You might be thinking, how is word boundary different from a start of string? So as you can see here, word boundary cares about all the words of a string, whereas start of string looks only at the starting point of the string and nothing else. The next thing to tweak is if it should be found when surrounded by something else. So for this, we have something called look ahead and look behind. So our pattern should be present, but there should be something ahead of it. This makes it a positive look ahead. If that thing should not be present, that makes it a negative look ahead. As an example, we want to find the mentions of JavaScript in the context of an error. So we can say that search for JavaScript followed by a positive look ahead of error. We'll find all the mentions of JavaScript only when it is followed by an error word. Similarly, if we are looking for how many mentions of Java but not of JavaScript because it's a different language, we can write Java and a negative look ahead of script. So here the first two sentences won't be captured, but the third sentence will be captured. Now imagine if we want to search for mentions of berry and that they are sweet. So we can write berry with a positive look behind of sweet. So as you can see, sweet strawberry is detected, whereas strawberry alone is not detected. Now again, let's say we are looking for any kind of berry, but not halle berry. We will write berry with a negative look behind of halle. So in this case, strawberry and wild berry are detected, but halle berry will be rejected. The atomic group is something which you can look in a future video. If you want to learn about it, do let me know in the comments. One more thing, you should know how to handle special characters with tender love and care. For example, if you are searching for .com, it will match all these three sentences. Do you know why? Because the dot is a special character. It can match anything, including the dot itself. So if you want this dot to behave like a literal character, you just have to put an escape character, that is the backslash, just before the dot. Now it behaves like a normal literal. So in this case, .com will be the only text which is matched and any other mentions of com will not be matched. These are some other special characters for your reference. Now finally, we are going to look at the return groups. So let's say if you want to find out the user ID of any email. So we'll start with what we know. An email will definitely have @ sign. So if our regex is @ it will match this part. And if it is .com, it will match this part. So let's combine these two to create this pattern and put a dot with a plus sign. So anything in between @ and .com gets matched. Great. Now similarly, we want to match things before the @. So again, we will put a dot and a plus, which will match anything. And just to make sure we capture everything, we can put a start of string tag so that anything from the start gets matched over here. So as you can see, this part captures John, the @ literal captures @, this part captures Gmail, and the .com literal captures the .com part. Now let's say we are interested in getting only John, that is the user ID from this entire string. This is where return groups come handy. This regex matches John @ gmail.com. So if we want to return John, we'll put a bracket around the part which matches John. So everything before the @ sign, we will put a round bracket, and now when we run this regex on this piece of string, it will return John. Similarly, if we want to return the email provider, we can put a round bracket around the part which matches the email provider. So in this case, it will be the dot plus after the @ and before the .com literals. One last thing, regex patterns are case sensitive by default, and you can make them case insensitive by applying modifiers or flags depending on the language of your choice. And if you want to practice your regex skills, I would highly recommend this website called Regex 101, where you can input your string and your regex pattern and see how the matches will occur. These videos and animations take a long time to create, so please support us by subscribing our channel.